Good morning, students. Those who are online, are you able to hear me? But I'm not able to hear you. Can someone speak? Okay, that is a problem. Okay. Yeah, now can someone speak? Yeah, now can someone speak?
Yes, sir, you are audible.
Yeah. Okay. Yes. So as we discussed yesterday, first 10 minutes, write the derivation. Okay. So those who are online, I'm expecting you to write it sincerely. I can't make you switch on the video and write it. So write it sincerely and submit it in the app. Those who are online, I hope you all submitted. On. Which one? No, no, no. This one will come. Yeah. Okay. So this is a formula that we have seen, right? P is equal to mu naught I divided by 4 pi into A into sine of alpha, sorry, sine alpha plus sine beta, and that is what you try to derive now. Okay. Let's try to apply the same concept and see. You can write it later. You can write it later. Now listen. Let's see some special cases. So when I say special cases here, first we are going to talk about a conductor which is infinitely long. Okay, a conductor of how much length? No. Finite length is the derivation. This is also an application. Mostly we'll be using only infinite and semi-infinite. Okay. So when I say it is of infinite length, okay, what is the meaning of this? Say, suppose I have a point P here, and this distance is A, accepted. So when it is of infinite length, if I try to draw a line from here till here, okay, and we know that this angle is alpha, where will that angle alpha get extended to if it is an infinite length conductor? So alpha will be equal to pi by 2. and beta will be same pi by 2. Are you guys convinced with this? Why is it so? Because only parallel lines will be able to meet each other at infinity. So this should also become a parallel line to whom? Parallel line to the conductor, and this will also be a parallel line to the conductor. Now, if this is the case, we know that B is equal to mu naught I divided by 4 pi into A into what is it? Sin alpha plus sin beta. So can I write it as sin pi by 2 plus sin pi by 2? So if I write it like this, what am I going to get there? Mu naught I divided by 4 pi into A into 2. Accepted? So this will be equal to mu naught I divided by 2 pi into A. So this is the value of magnetic field due to an infinite length conductor. Is that clear, guys?
Yes, sir.
Good. Tell me.
So, why are they taking alpha and beta?
Why are we taking?
Alpha and beta as final.
Because they are infinite length. No. If this is extending till infinity, this is also extending till infinity. If I try to draw a line from here till here, what will happen to this alpha? This alpha will keep on increasing. No. It will go in this direction and it will become pi by 2.
Yes, sir.
Because they are of infinite length. So this and the conductor, the line, the dotted lines from P and the conductor itself will become parallel to each other. When they become parallel to each other, what is going to happen? Alpha will become pi by 2. Clear? Okay, this is a simple thing. Yes. So the second case is when you take a conductor of semi-infinite length. So what do I mean by semi-infinite length here? Means if this is a conductor, okay, for example, and if I take the point P to be at the bottom of the conductor, okay, when I take it to be at the bottom of the conductor, then this distance will be A. In this scenario, what is the angle made by the bottom, angle made by the line from the bottom with point P? So alpha will be 0, then what about beta? Beta will be pi by 2 because this keeps increasing. And this is what is beta, it becomes pi by 2. And the current is still I, right? Having said this, what can I say is the value of magnetic field going to be? P is equal to mu naught I divided by 4 pi A into sine 0 plus sine pi by 2. So how much is answer, guys? Mu naught I divided by 4 pi into A. Accepted?
Sir, so basically for infinite, we are taking both ends to be extending, whereas in semi-infinite, one end is being fixed, right?
Yeah, semi-infinite means what? No, it's not fixed. It's not extending, by the way. One of the ends is taken parallel to point B. That is what I meant. Okay. If you have a conductor, even if it is of infinite length or semi-infinite length, whatever it is, it has some endpoints, right? So let's say when it is semi-infinite, let's say there is an endpoint. Then I will take that endpoint itself as the reference point. That is what I meant.
Okay.
Yes. So it is going to be B is equal to mu naught I divided by 4 pi into A. Is that clear? Okay. Now what we'll do is we'll try to solve a problem based on all the concepts. Find the magnetic field due to a square shaped loop at the center of it. So meaning is if I have a square shaped conductor like this. Okay. If I have a square shaped conductor, let's say it is of side A. Okay. And you have a point P here. Okay. Now listen to this. If this is A, B, C, and D. Okay. The current in the loop is going to flow, let's say, in the clockwise direction. When this is going to be the scenario, our job is to find the value of magnetic field due to this kind of a system at point P. Okay. So how do we proceed? So if I take this as conductor number 1, 2, 3, and 4. Root 2, we'll see. So let's say the magnetic field due to the first conductor. If I call the magnetic field due to the first conductor as B1, then what is going to be the value of B1 at point P due to the first current carrying conductor? B1 will be equal to mu naught I divided by B1 is equal to mu naught I divided by 4 pi into A into sine how much? Why is it 45? Because if you join from here, right? So this is going to be how much? Okay. If these two are 45, then if I draw a line from here, then this 90 is going to get divided into two 45s. Okay. So tell me one thing. This is also 45, and the angles at the center is also 45. Which 45 did you take into consideration? The angles at the center or the angles near the conductor? Angles at the center, because that's what the formula says. Sin alpha plus sin beta is the angle subtended by the lines near the point where you're trying to calculate the filter. Be careful, because in this case, everything is same. So some of you might think that I took the bottom 45, some might think that I took it at the center. I reiterate this. Whenever you take the angle sin alpha plus sin beta, the alpha and beta should be taken closer to the point where you're trying to calculate the field. So this 45 is what I have taken into consideration. So sin 45 plus, tell me.
Sir, why are you taking at 45, sir? I didn't get it.
It's basic geometry. Is 90, diagonal it will bisect it. So this is 45, this is also 45. Upper in the center it will be 90. It forms an isosceles triangle. Again, the drop a perpendicular. That will also be an angular bisector, 45, 45. That's it.
Fine, sir.
I have to change that. Okay. So mu naught I is okay. 4 pi into, when I say A, in this problem, A represents the side of the square. Don't get confused with that. So I need to take that A to be the perpendicular distance from the current carrying conductor to the point where you're trying to calculate the field. So how much is the distance? It is going to be A by 2. So 4 pi into A by 2 into sin 45 plus sin 45. So how much am I going to get? Mu naught I divided by 2 pi A into 1 by root 2 plus 1 by root 2 is going to be root 2. So is this what you told? Mu naught I by root 2 pi A? Huh? This is what you told, right? So this is the value of P1. Okay. But here we need to be careful with one thing. What is the value of, so the value of magnitude is mu naught I by 2 pi A into root 2. Accepted. But what about the direction? So if I have to write it as a vector quantity due to the current going in the upward direction, what is going to be the direction of magnetic field at point P? It will be into the plane or out of the plane? It will be into the plane. Into the plane means, can I call it as minus k cap? Accepted. Then what about B2, guys? I'll give you 1 minute time. Find out what is B2 and tell me. Is it the same or different? Same. So it will be mu naught I divided by 2 pi a into root 2. But what about the direction? It is still the same. What about B3? Then what about B4? Why I told is because many people, what they think is, since the current in the opposite conductors are in opposite direction, they'll think that the direction of magnetic field will also change. But unfortunately, it will not change because the magnetic field that you're trying to find is always perpendicular to the direction of current. So when it is going to act perpendicular, right, in both the scenarios, it will be into the plane. Okay, so that is why you are getting minus k cap at every place. So net magnetic field, if I use the principle of superposition, so wherever you have vectors, you can go with the concept of principle of superposition. So it will be equal to B1 vector plus B2 vector plus B3 vector plus B4 vector. How much will the answer be? 4 times root 2 divided by 2 pi a into I. Sorry. Mu naught I, which is minus k cap. Now this 2 and this will get cancelled. It will be 2 root 2 times mu naught I divided by pi into a times minus k cap. Except, no. 4 root 2 is there. No, that cancel that 2 and 2. That 2 and 4. This one now. Correct only, no? Check it again. So each value is mu naught I into root 2 divided by 2 pi m. So it is getting added 4 times. So 4 times mu naught I into root 2 divided by 2 pi. That's it. Correct? So those who are online, you're able to understand.
Yes, sir.
Okay. Shall I proceed? Now, after this, we will see the next concept. So, do you all have textbooks? So, in that you have a concept called as magnetic field due to a circular current carrying conductor. Okay, write down the heading: magnetic field due to a circular current carrying conductor on the axis of it or on its axis. I'll tell you the page number. This is the one. Okay, you're able to see this, right? Okay, I want everybody to concentrate. There's a tricky part. Listen. So what is the heading? First of all, have a clarity on what they're asking. Our job is again to find magnetic field. Due to whom? Due to a current carrying conductor. But this time the current carrying conductor is taking a closed shape. That is in the form of a circle. Okay. And with respect to circle, you have different points, or you have different parts, I would rather say. You have the circumference, you have the center, and you have something called as axis. So first we need to understand what exactly do they mean, right? So if I take a circle like this, right? So with respect to the circle, this is what we call it as circumference, okay? The center is this point. Okay, now what is this axis we are trying to talk about? Where is the axis? So if I take a circle like this, how is the axis going to be? So axis is something which is perpendicular to the circle itself, and it should pass through the center. That is the natural axis. So it looks something like this, right? But what will happen is, if we have a diagram of this sort, it will be slightly difficult for us to go with the derivation, because we can take in whatever way we want. So in this case, they have taken the current to be in the anti-clockwise direction. Okay. So imagine you have a circle like this, and if you see the circle from this side, the current is flowing in the anti-clockwise direction. So you're able to see a complete circle. And this is how the axis is towards you and back of it. Okay. Now my question is, if I have to see the circle like this, if I'm tilting the circle and putting it like this, how will it appear? So imagine, okay, this is the circle. Imagine you see it from this side. I'll call it as x-axis, y-axis, and z-axis. Okay. If you see it from the z-axis, if you see through the z-axis, it will appear like a circle. If you see from this side, if you see from x-axis, how will it appear? It will appear something. It will appear like a straight line, right? So I don't want both of them. I want something intermediate between them. So I'll tilt it like this. So it will look like a oval-shaped figure. It is actually not an ellipse, but it will look in the form of an ellipse. And that is what the diagram they've given gives.
Sir, we are not able to see your video, sir.
Which video? No? Shared? No, man. Check. My video is on. I think you're seeing on something else.
Yeah, yes, sir.
Okay. So when I keep it like this is a path. Current is flowing in anti-clockwise direction. So I told you yesterday, right? DL has direction associated with it. But DL will take the direction of whom? It will take the direction of current. So at the top, when you take it, this will be the direction of DL. And at the bottom, this will be the direction of DL. And they both are tangential to each other and anti-parallel at each other. At the top, it will be in this direction. At the bottom, it will be in this direction. Are you able to visualize that? Okay. So having this in our mind, so I'm taking a shape of this form. Okay. So at the top, I'm considering a small current carrying element DL, and at the bottom also I'm taking a small current carrying element DL. Okay. So the direction of current is in this way. At the bottom, the direction of current is in this way. Are you able to visualize this? Right. Then this is still going to be the center. I'll be able to see the center. But now axis is going to be more clear to our vision. Right. So when you take it like this, then this will be the axis. Correct? So on the axis, if I take a point P, our job is to find what is the value of magnetic field due to this whole current carrying conductor at point P. Okay, now let's start giving values to it. So let's say the radius of the circle in this scenario is A. Repeat, radius of the circle is A. Okay. Distance from the center to the point P is X. Okay. So if I join the points DL to P using a dotted line, okay. If I try to draw a line from there, then what is that distance going to be? Root of A square plus X. Okay. So all these things are easy, simple math. Here comes the tricky part. I can solve this only if I am able to find what is the direction of magnetic field due to the small current carrying element at point P. That is where the trick starts. Okay, how do we proceed? Just give me a minute, I'll see if I have a circle. So this is there, right? Now, if I take this to be the circle, then this is how we are seeing it. Correct? So at the bottom, at the top, the direction of current is like this. and at the bottom, the direction of current is like this. Correct? Now comes the question. For this, on the axis, this is the axis, you have a point. Okay. So, if this is DL, I repeat it, listen to this. If this is DL, and this is the point on the axis, and if this is the point on the axis, then if you see it like this, if you see it like this, right? What can you say is the angle between DL and this R vector? Are you able to see that? So I tilt it like this, you're able to see it. So howsoever you keep it, right, it will be 90 only. Howsoever you tilt it, it will be 90 because the lines will get adjusted in such a way. Why is this happening? Is because on the rim of the circular current carrying conductor, you can take DLs at multiple places. Okay, if I keep it like this, if I take this as DL, from this DL, if I join it to this point P, I take all these DLs, what will all those lines give us? They give the shape of a cone, right? And for the cone, the distance from the center to this point is always going to be X only. That is the height of the cone. And this distance, which I'm trying to talk about, will it be the same R for everything? Are you guys able to visualize this part? So what I'm trying to say is, this is R. Root of A square plus X square is what is R. Why I took the angle between the current carrying element and R is because what does the formula of Biot-Savart law tell us? dB is equal to mu naught I divided by 4 pi R square into sine theta. Now let's try to answer each of them. Mu naught is a constant. I is the current through this conductor, accepted. R is what? R is the distance from the current carrying element to the point where you are calculating field. In this case, what is the value of R? Root of A square plus X square. But what about sine theta? In this case, theta is equal to how much? Angle between the current carrying element and this thing. So you're able to see it, right? It is going to be 90 degrees. Right? So if you have answered this question, first step is over. Okay. So I can take this and substitute it here. I'll get dB is equal to mu naught I divided by 4 pi R square into, or I'll write it like this, 4 pi into A square plus X square into sine 90. Observe this step and ask if there is any doubt. So I repeat it, I wrote it as mu naught I divided by 4 pi into A square plus X square because it is root of A square plus X square the whole square. Purida. So this is what is.
Sir?
Tell me.
Sir, where's the DL, sir? dB equal to U naught I DL by 4 pi R square sine theta.
Yeah, DL I forgot. Okay, mu naught I DL. Yes. So into sine 90. Sine 90 is obviously going to be 1. So I got this. Okay. Once you achieve this, the next step is you need to see what are all the variables because we need to integrate it. Right. So for us to integrate, you need to see what are all the variables. What are all the variables you're able to see in this? Except DL, there is nothing. A is a constant, radius of the circle. X is also a constant in this scenario because we kept that X as a fixed value. Right. So our job is to write DL, is to integrate DL. But if we integrate DL, from where to where am I supposed to integrate? Okay, sorry, I have something else to tell you. Here we found dB accepted, but what is the direction of the dB? This is another part. Okay, visualize it. I want you guys to think and tell me. Okay, if this is the value of ideal, and this is the direction of R vector. So when you see it like this direction of DL, this is the direction of R vector. Then how do you find the direction of magnetic field? It tells you as I into DL vector cross R vector. So DL in the direction vector, R is in this direction. So using the right hand thumb rule, can you tell me what will be the direction of magnetic field? So if this is the direction of current, right? And curl the fingers at the bottom. In which direction will it be? It will not be into the plane of. Observe it now. Where are you calculating? This is very, very, very tricky part. If there is some, you're done. Okay. This is DL. Okay. This is R vector. Ideal cross R vector. When you do this at the point P, look at my fingers. How are they coming? They're coming in this direction. So they will actually look something like this. This is actually the direction of DB due to the top element. But I'll simplify this and tell you how to find it. Okay. Listen to this carefully. Now, if I take this point to be the origin, what am I doing? I'm taking that as the origin. If I take this as the origin, then this is the direction of DL and this is the direction of R vector. Okay. So when this is being taken as origin, okay. Now tell me, this DL is entering into which quadrant? Okay, I'll take it like, okay, I'll make it even more simpler. Wait. So this is the circle. So at the top, right, this is I. And so you're visualizing the circle like this only. So this is the direction of I. Can you tell me the direction of I? That is DL vector is in the direction of minus I cap. Correct? Accepted. Why it is minus I cap? Okay. If that is the scenario, then what is the direction of R vector? R vector is somewhere over here. It is towards you. Okay. From here, what will be the direction of R vector? Had it been straight, you would have called it as Z-axis. But here it is not straight. It is inclined. So what will be the direction of it? Direction, I don't want the magnitudes and all. Tell me in terms of I cap, J cap, and K cap. If it is K cap, it should have been straight. It is in which direction? It is in direction of minus J cap and K cap. So R vector is in the direction of minus J cap plus K cap. Why? Because if I take this as the origin, okay, x-axis, y-axis, positive z-axis. So this R is entering into which axis? Z-axis and negative y-axis. So it will be minus j cap plus k cap. So how do you find the value of dB vector? dB vector is calculated using dl vector cross r vector. So what is dl vector cross r vector? So this will be minus I cap cross minus j cap plus k cap. Right? Minus I cap. So it will become minus I cap. See, do all these work as rough work, okay? Minus j cap plus minus I cap cross k cap. So what is I cross j? So if you don't remember this, right? Make a note of it. Take I, j and k in the anti-clockwise direction. Then I cross j will be equal to k. J cross k will be equal to I, and k cross I will be equal to j. Similarly, so anti-clockwise is positive and clockwise is negative. That's it. So when you say this, minus of minus plus. So what is I cross j? So can I directly write it as k cap? K cap plus. What is I cross k? So minus j cap, but minus of minus will become a plus. Are you guys able to understand this? So it becomes j cap plus k cap. What happened to it? It became j cap cross k cap. Again another. Now again coming back to the diagram, we'll revisit. Now have everything in mind. You're seeing. I'm seeing the conductor in this way. Okay, I'm seeing the conductor in this way. This is the direction of I. In the anti-clockwise, according to you, this is the direction of I, which is in the direction of negative x-axis, other minus I cap. Where is r vector? It is going into negative y and positive k. That is why I wrote it as minus j cap plus k cap. So by doing the cross product, I got the direction of dB as j cap plus k cap. So j cap plus k cap in the direction of. So if this is minus j cap plus k cap, so this is k cap, then isn't this going to be the direction of j cap plus k cap? Then what will happen in this scenario is, this will be the direction of dB. Small correction, this is not the direction, this is the direction of dB. Okay. Now listen. How to connect all the dots is, next time onwards, if you see this, right? Listen, if you see this, this is the direction of I vector. So keep your thumb like this. So keep your thumb like this and curl your fingers. So when you curl your fingers at point P, look at these fingers. In which direction are they going? They're going in this direction. Right? So if you get that hint right, one important point that you need to know from the basics of vectors is, when you're doing the cross product between two vectors, the resultant will always be perpendicular to both the vectors for which you're doing the cross product. So once you find dB is in this direction, blindly what you can do is, to this r vector, draw it perpendicular. Are you able to understand? So dB, r vector and dl vector, all the three are mutually perpendicular to each other. Is it clear? So using the same logic, okay, I'll give you 2 minutes time. Think about it. If there is any doubt, get it clarified. I want you all to think and tell me what would be the direction of magnetic field due to the current carrying element at the bottom. So due to this current carrying element, what will be the magnetic field at point B? Find out and tell me. Visualize it. Try it out. Try it out. So whenever you're finding the direction using vectors, first thing is, you should take the point where dl is present to be the origin. So in the previous scenario, dl was at the top, so I took that as origin. In this scenario, where is dl? At the bottom. Take that bottom as origin and do all these steps as rough work and tell me what is the direction of dB. Even if it is wrong, it is fine, but try it. Try it.
Sir,
Tell me.
sir, is it minus I cap cross K cap minus J cap?
Sorry, ma. You're saying the answer?
No, sir. I have a doubt. Isn't minus I cap cross K cap minus J cap?
No. I cross k is minus j. Minus of minus j is plus j.
Okay, sir.
So when you're writing, no, ijk should be written in the anti-clockwise direction. Have that in your mind. So this is the final result. So you took at the bottom, right? So when you take the value of dl at the bottom, this will be the direction of current. Correct? So dB vector is given as dl vector cross r vector. This is very clear. So I need to find the direction of dl. dl and the direction I cap cross, what is the direction of r vector? So if I take this to be the origin, inge poguma, r inge irukum. So where is r? So r is somewhere over at the back of it. So it will become j cap plus k cap, because it is entering into the first quadrant of that particular YZ plane. Okay. So I cross j nedutha, what is I cross j? It is k cap plus I cross k is how much? Minus, correct. So minus j cap, in which quadrant is it going? It is going in this direction. So this is the value of dB. Is that clear? Is it clear? which point want to do. This one you understood. I cap you understood. Okay. So j cap cross k cap n patana. This is the direction of dl. Correct? Sorry, current. Oh, sorry. This is the direction of dl. With respect to you, this is dl. Up in your point recognition. Okay. From here, in which direction is it going? You have to take this point as the origin. If you take this as the origin, either positive, either x-axis. This is y-axis. This is z-axis. Okay. Y is at Nyabashko. From here, if the point P is here, okay, what is this direction? Positive y, positive z. Up and over. Positive y another. J plus j kappa minus j kappa. Plus j kappa. So positive y, positive z. That's plus j cap plus k cap. Now do the cross product. I cross j on the k. I cross k on the minus j. So minus j in the quadrant. So this one the y-axis na. This is minus j. So minus j plus I plus z. So up in the quadrant. So this is how the direction of magnetic field at this point is. So this is the value. Okay. But I hope you guys are clear that this is also root of a square plus x square because it takes the shape of a cone. Clear? So dB, if you take it at this point, right? These are the values of dB due to whom? Due to the small current carrying elements. But I'm interested to calculate the direction, the magnitude, the total magnitude at this point. So what we are supposed to do is, if I take this to be theta, okay? So in the theta is not the same as that sin theta I'm trying to talk about. This is theta. This is 90. Then how much will this be? 90 minus theta. Now I can resolve this dB into two components. So is 90 minus theta is theta accepted. This is also theta accepted. Okay. Now this dB can be resolved into two components. What are they? dB cos theta, and dB sin theta and dB sin theta. Which components get cancelled? Cos theta components get eliminated and dB sin theta is what is left out. So how many dB sin thetas are there? 2 dB sin thetas are there. So the net magnetic field at point P is dB dash, I'll call it. It is 2 times dB sin theta. Okay. So 2 into, listen to this again. 2 into, what is the value of dB we got in that expression one? Can you tell me? Mu naught I divided by 4 pi into a square plus x square into Vandrukom multiplied with, yeah, I'll come to that, into sin theta. Now our job is to find sin theta from this triangle. So what is sin theta, guys? That is simple. Look at the diagram, tell me what is sin theta. A divided by root of a square plus x square. So upper 2 mu naught I divided by 4 pi into a square plus x square into what did you say? A by root of a square plus x square. Okay, 2 more steps and we are done. So dB dash is this value. So cancel this and this. So dB dash will be equal to mu naught I into a divided by 2 pi into a square plus x square the whole power 3 by 2 times dl. Accepted. See, this derivation is tricky only because of 3 dimensions getting involved. Okay, but there is no other option. We have to work on it. So if this is the value of dB dash, then what is going to be the value of b dash? Integral of mu naught I into a divided by 2 pi into a square plus x square the whole power 3 by 2 times dl. Correct? Now what are the limits I need to take? So if dl starts at the top, okay, listen, how many dls did we take in this problem? 2. So there is one DL at the top, one DL at the bottom. So when this DL starts moving, this DL will also start moving. So by the time this DL covers a distance of half the circumference of the circle. So I'm sorry. By the time this DL covers half the circumference of the circle, the second DL would have covered the remaining half of the circle. So each DL is covering how much distance? Half the circumference of a circle. So one common mistake that happens here is, since they see integral of DL, they write it as 0 to 2 pi a. No. So you will write it as 0 to 2 pi a if you have considered only one DL. If you consider two DLs, how much should you make? You should make it pi a. Sorry, pi a. Okay. Suppose you have considered 4 DLs. 1, 2, 3, 4. Then how much should you take it as? Pi a by 2. So you have to keep dividing the circumference with the number of DLs that you have considered. So it becomes 0 to pi into a. Now observe, this is a very simple integration. Take everything out except DL. So you will have mu naught IA divided by 2 pi into a square plus x square, the whole power 3 by 2 into integral of DL from 0 to pi a. So it becomes mu naught IA divided by 2 pi into a square plus x square, the whole power 3 by 2 into integral of DL is L. Between 0 to pi a will be pi a. So pi and pi will get cancelled. A and a will get multiplied. You will have the answer as mu naught I a square divided by 2 into a square plus x square, the whole power 3 by 2. So this is going to be the final expression. Okay. And you're expected to remember this output. This value is to be remembered because we'll use it in a derivation called as solenoid. At that point, we'll be using it. So, yeah. So there are some special cases also involved that we'll discuss tomorrow. Till then, you can copy this. This fine? More? This fine? Okay. So before I forget, tomorrow also the first, I'll give 15 minutes time for this derivation. It's very important. This one. Practice it and come. Practice it and come. Okay. Tomorrow be on time. We'll do two things. I'll do a fair deal. Be on time, study and come. First 5 to 10 minutes, I'll give you time to ask doubts. After 10 minutes, I want you to write. Even if 20 minutes goes, I'm not worried, but I'm very much concerned about this derivation. Is that clear? So first 20 minutes will be discussion and a small test. So study and come. And don't be late. Sariya, naale ki excuse la mana. 5. Tomorrow 5. Yes. Now the notes share pandra you can have a look. Somebody is copying, right? Did you guys copy it? Which paper? This one, huh? This you can take it tomorrow. Yeah. Those who are online, any doubts, guys?
No, sir.
No, sir.
No, sir.
Okay. Yeah. You can wind up then. I want you to write the one which I taught. Can I close it?